Okay, hi guys, sorry that's not for you. I'm sure you wish it was. That's actually my grade 9. So based on some of the messages that I got, I don't think that page 238 and 239 went too well, because I had people asking me questions about 12, about 15, about 10, different parts for everybody. So I think the easiest thing to do is I'm just going to do them, okay? So I'm going to do the homework from page 238 and 239. I'm going to be posting that today, which is Wednesday. I'm going to be posting that today. And then you guys are working on the social sciences section. And I think I gave you until Thursday night to finish that and ask me questions so that if I need to make a video on that, I can have that ready for Friday. And then we'll probably talk about antiderivatives on Friday. So page 238, the questions that you had to do were 10, 12, and 15. And honestly, there seem to be some questions on a lot of that. So number 10. Number 10 talks about a motorcycle. The position of a motorcycle is given by 1/2 t squared plus 15t. T is measured in seconds, S is measured in meters. When they ask when, we're always looking for a time. When does the motorcycle hit a velocity of 15 meters per second and a velocity of 25 meters per second? So that's part A. And part B says, what is the acceleration of the motorcycle? So for this one, I gotta grab Harriet a sec. There we go. For this one, velocity is the derivative of position. So I'm going to bring the 2 down. So 2 times 1/2 is 1. So that's just 1t plus 15. So it says when, at what time is the velocity 15 meters per second? Well, that would be at 0 seconds. So when I start timing this individual on a motorcycle, they're already going 15 meters per second. And when are they going 25 meters per second? Well, again, I just bring it over here, and that would be 10. So at 10 seconds, they're going 25 meters per second. In terms of acceleration, acceleration is the derivative of velocity. It turns out to be a constant because when I take the derivative, that's 0. Actually, no, sorry, I lie. My apologies, that did seem like a huge acceleration. If I take the derivative of this, the derivative of t is 1, the derivative of 15 is nothing, not 15, which is what I was doing in my head. So the acceleration is 1 meter per second. That's a whole lot more realistic. So that's it. That is number 10. That was easy. Thank you. Just so you know, I picture you guys going, oh, and the light bulb's coming on. Number 12. Number 12 says, okay, you've got a motion detector and it's graphing the position of a sports car. So it's basically just tracking the sports car. If the motion detector is not calibrated properly, it'll give unrealistic data. So the position is 2t cubed minus 21t squared plus 60t. And they say that this applies from 0 to 6 seconds. So the motion detector is only detecting the motion for 6 seconds. It says, it is known that the largest possible acceleration of the car is 12. So we know that whatever kind of car this is, the fastest it can accelerate at is 12 meters per second. It can't accelerate any faster than that. and its acceleration depends a lot on torque, which, hey, if you're going to do physics, that's what we're talking about next is torque. But that doesn't really matter for this question. That's just me rambling. So 12A, they want to know what is the initial velocity of the car. They want to know when is the car at rest. And they want to know when is the car moving forward. Okay? So we have to do those 3 things just for part A. So let's look at each one of those individually. So first off, in each of those, we're talking about velocity. So the first thing we have to do is figure out a velocity formula. And velocity is the derivative of position. So this is 6t squared minus 42t plus 60. Now they want to know what's the initial velocity. Initial velocity is exactly when it begins timing, exactly when this motion detector begins working. At time 0, how fast is the car already going? So time, at any time you have an initial anything, time is always 0. So all I'm going to do is put 0 in for my time, and I get that it's 60 meters per second. So initially the car is going 60 meters per second. Then it wants to know, when is the car at rest? When is the velocity 0? Now, if you want, you could factor this way, but I would notice that either you could take a common factor of 6 out, or you could just divide everything by 6. And I would have t squared minus 7t plus 10. So that would factor to t minus 5 and t minus 2. So t would be 5 or 2. So when is it at rest? It's at rest at 2 seconds and at 5 seconds. Now, when is it moving forward? When is it moving away from its origin? It's moving forward when the velocity is positive. So that's another one of those. I'm going to set up a little grid here. I'm going to set up a little table. And I know at 2 and at 5 seconds, it's stopped. Well, the car has to momentarily stop either moving away or toward in order for it to turn. It's got to stop moving to turn, whether it's going to do a donut or whatever to get itself around. It has to stop. So at 2 seconds it stopped, and at 5 seconds it stopped. So what I'm going to do is I'm going to check, is my velocity positive or negative before 2 seconds, in between 2 and 5 seconds, and after 5 seconds. But remember, I'm restricted in choosing for t anything between 0 and 6. So if I choose a number before 2, well, I already did, because I put 0 in for my time and I got a positive answer, which means the car is moving forward because it's moving away from its origin. If I choose a number between 2 and 5, any number you want between 2 and 5. So if I pick 3 and I put it into my velocity formula, if I pick 3, 3 squared would be 9 times 6 is 54, minus 42 times 3 plus 60, I get a negative answer. I actually get negative 12. So that means it's moving, we'll call it backwards. It's not moving forward, it's moving back towards its origin. And then anything after 5, but I can't just pick any number after 5. I can only go as high as 6. So I would actually choose 6. So 6 squared is 36 times 6 minus 42 times 6 plus 60. I actually get a positive 24. So the car is moving forward again. So the car is moving forward from 0 to 2 seconds and from 5 to 6 seconds. That's when the car is moving forward, because that is when the velocity is positive. So that was 12A. So I'm going to leave, so it's moving forward from 0 to 2, and from 5 to 6. That's when it's moving forward. I'm going to leave, let's see, I'm going to leave that much on the board because I have limited board space. Part B wants to say, it says draw a diagram to illustrate the motion of the car. Again, that's not fancy. From 0 to 2 seconds, it's going forward. From 2 seconds to 5 seconds, it's going backward. And then from 5 to 6 seconds, it's going that way. So really, the car is doing this. That's all I really want for a diagram. It doesn't have to be fancy. They just kind of want to know, can you picture in your head what's going on? So that's B. C says find the total distance traveled by the car in the first 6 seconds. So you can't just put 6 into your position, because if you put 6 into your position, all it tells you is how far away from its origin it is. It doesn't tell you the total distance. I did a question like this in class a day or two ago when we did the cheetah question. So I know for the first 2 seconds it goes this way, but the question is how far does it go in those 2 seconds? So the first thing I would do is I would take my position, because I want to know what position is it in when it stops the first time. So I would do position, and I would put 2 in as my number. And I would work out what that is. So 2 cubed is 8, times 2 is 16, 2 squared is 4, 4 times 21 is 84, plus 120. I get 52 meters. So in the first 2 seconds, it ends up being 52 meters away from its origin. So far it's traveled in terms of distance. I'll put it down here. So far in the first 2 seconds, it's traveled 52 meters. Now, the next time it's going to shift direction is at 5 seconds. So again, I'm going to figure out its position at 5 seconds. So I'm going to put in 5 for my time. I can't talk and do it at the same time. I don't know why. So I'm going to do 125 times 2 minus 21 times 25 plus 60 times 5 would be 300. It's 25. So at 5 seconds, it's 25 meters away from its origin. So if it was 52 meters away from its origin and now it's only 25 meters away from its origin, how far did it travel? Well, I would have to do 52 minus 25. That's what I would have to do, because I need to figure out what's the difference between those two distances. What's the difference between being 52 meters away from my origin and 25 meters away from my origin? Now, when it's done, 6 is my last time. So I'm going to figure out the position again. I'm going to put 6 in as my time. And I'm going to figure out where it is at that point. So 6 cubed times 2 minus 21 times 36 plus 360 is 36. So its position at 6 seconds is 36 meters away from its origin. So at 5 seconds it was 25 meters away. At 6 seconds it was 36 meters away, which means it traveled 11 meters, right? It went from 25 to 36. That's 11 meters if I did the math in my head right. So plus another 11 meters. So the distance is going to be 52 meters in the first 2 seconds, and then 52 take away 25 should be 27. So 27 between 2 and 5 seconds, and 11 in that last second. So that gives me a total distance of 90 meters. So the total distance that the car traveled is 90 meters. That is part C. Part D, find the maximum acceleration of the car. So acceleration is going to be the derivative here. So it's going to be 12t minus 42. My maximum acceleration, because this is not exponential or anything, my maximum acceleration is going to happen when my t is the biggest it can be, which is, I think, which is going to be 6. So if I do 12 times 6 minus 42, 12 times 6 is 72. Did I do that right? Yeah, I did. And then minus 42. So 72 minus 42 is 30 meters per second. So according to this, the car's maximum acceleration is 30 meters per second squared, because we're assuming that it's accelerating through the entire trip, through the entire 6-second trip. So the last one is really just a can you interpret your data question, because it says list all the evidence that you can show the company that the equation of motion is not realistic for a sports car. You really only need one piece of information here to prove it, because back at the beginning it said this car, we know that whatever sports car this is, it can only accelerate at 12 meters per second squared max. However, according to the equations that we use, the max acceleration is 30 meters per second squared. Well, that can't be true if we already know mechanically the car can't do that. So if the car can't do that, those equations don't make sense. You really only need one reason why it doesn't work, and that would be my reason. So that's number 12. And then finally, question 15. Question number 15 says, I don't know what. Question number 15 says you've got a stunt car driver and they're practicing, and I have to pick it up because it's too far away. You have a stunt car, they're practicing. The position formula is 1/3 t cubed minus 25t. And all it says about t is that it has to be bigger than or equal to 0. Sorry, Wicked is talking down there. It says find the acceleration at the instant the velocity is 0. Find the acceleration when the velocity is 0. So since we're talking about both acceleration and velocity, I'm going to need both of those. So velocity, if I bring my 3 down, it's going to become t squared minus 25. And acceleration then is going to just be 2t. So it says find the acceleration when the velocity is 0. So the first thing we have to figure out is when is the velocity 0. So when means I'm finding a time. When is my velocity 0? So I'm going to put 0 in for my velocity, and I'm going to figure out the time. So it's going to come over here. So t squared is 25, so t is 5. So the velocity is 0 at 5 seconds. So what is the acceleration at that point? Well, that would be 2 times 5, which would be 10 meters per second squared. That's number 15. Hope this helped. If you have any questions, rewatch the video a couple of times. That is the bonus of having these videos, is you can rewatch any piece that you need to watch, because I know I talk fast. So you can't rewind me and rewatch me at school, but here you can do that. So that's a kind of a nice feature about all this craziness. And if you have any problems in the next section on the social sciences, let me know and I'll do up a video like this to answer those questions as well. So keep communicating with me either on Google Hangouts or through Google Classroom. Either one works. Keep uploading any work that you do just so that I know that you're actually there alive and doing things. Otherwise, I have no idea. Veronica, if you're out there, let me know you're still there and that you are working on stuff, okay? Other than that, we'll see you again. Well, I won't see you. I'll talk to you again this way again soon. Okay, bye.